A very good morning and good afternoon, good evening, everyone, dear
Hello.
audience and invited guests. This is a technical session 5A, and my name is Richa, and I'm the moderator of this session. And on the behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 7th International Congress on Information and Communication Technology through Zoom. Further, as you are well aware, we have been facing a new normal situation overcoming the pandemic. Hence, the conference has been shifted to a hybrid mode. We are very thankful to everyone who present on this digital platform to go along with us digitally for this conference and making this conference more productive. We hope you will enjoy the knowledgeful session. Also, there's a special note for the presenters. You will be given 10 to 12 minutes for presentation and 3 minutes for question answer. After 10 minutes, I will raise a gentle reminder to conclude the presentation. And I request while the presentation is going on, kindly other participant kindly be muted. And there's another request to all the participants that you stay connected with us till the closing remark. If you have any query and any update, you can write it to me in a chat box. And just before we get started, I would like to introduce our chair, Dr. Gul. Dr. Gul is currently as associate professor in the School of Tourism and Hotel Management, Department of Tour Guiding, University of Sinop, Turkey. Dr. Gul has working as an internal trainer and a teacher in the tour guiding arena. Her doctorate in tourism management from the Sakarya University, Turkey. She has been invited for many talks, lecturer, panel discussion by different universities. The government of India has invited her to deliver a talk on a tour guiding and the University of Kota about the career in tourism. Taylor's University on tour guiding. She was invited a special guest of honor of many conference and organizations. She got awarded for several organizations. Thank you so much, ma'am, for giving us your precious time and your presence. Thank you so much, ma'am.
Most welcome, ma'am. Greetings.
And ma'am, now it's all over to you, all sessions.
Yes, surely, ma'am. Good morning, good afternoon, and good evening, wherever you happen to be. Welcome to our session of the 7th International Conference on Smartness in Computing and Communication. I'm Dr. Güler Kolbayram from Sinop University in Turkey. As everyone knows, everything has changed since the coronavirus. COVID-19 has affected human lives, the family atmosphere, the peace of social and economic development, and all of which have resulted in an incalculable loss of sustainable development. Still, there is no agreement about how ICT and communication technologies can help unify cross-country differences also. The COVID-19 pandemic has stressed every country's social and environmental and economic indicators and has challenges how nations can continue their sustainable and development also. At the peak of the crisis, many countries warned people that citizens stay at home. In times of crisis, such as the current COVID-19 pandemic and its economic and social repercussions, public governance matters more than ever. And ICT arrangements have played a critical role in countries' immediate responses and will continue to be crucial both to the recovery and to build a new normal once the crisis. At least for the foreseeable future, we face some interactions will be simply impossible. Restrictions, long quarantine times, and hygiene risks still hamper in many government activities. and people preferred online government models. Social distance will be the new mantra of today, and the role of communication in combating with COVID-19 of pandemic impact and promote the sustainable development goals. While people from all over the world are actively trying to avoid the crowd, they will also prefer internet-based activities, smart trends, communication technologies. In this case, we have a question, what will happen in the long run? In this conference, we will, while we try to seek some answer for this question, we also talk about smart trends on competing and communications and related these issues also. In this session, we will be talking about some solutions and challenges and issues for smart trends and competing. I would like to introduce to the speakers. The first presentation is entitled with Smart Wearable Shoes Using Multimodal Data for Visually Impaired. And this is presented by Enno Sayer. The second presentation is entitled with Internet of Things Automated Pill Dispenser for Elderly Care. This is presented by Dr. Aziz. The third presentation is entitled with an evaluation of technique for classification of conditional sentences and their structural components, and this is presented by Sander Gantner. The fourth presentation is entitled with peak shaving in microgrids using hybrid storage, and this is presented by Burak Lendik. The fifth presentation is entitled with preliminary results on constrained programming branch and bound algorithms for the cyclic bandwidth sum problem. This is presented by Valentina Narvaez-Tarek. The sixth presentation is entitled with Central Banking Digital Currencies as a new tool for e-government, Socio-Economic Impacts, and this is presented by Galia Kondova. There will be 6 speeches, and each speaker will have about 15 minutes for each presentation. 12 minutes for presentation and 30 minutes for question and answer. Yes, let's start the presentation. The first presentation is Enno Sayer. You can start.
Hello, everyone. I'm very happy that I have the honor as well to present my work to this panel. My work is mainly talking about smart wearable shoes using multimodal data for visually impaired. The main reason that motivates that work is the impaired vision people would like to work freely and comfortably outdoors and indoors. However, they usually fear the steps, the stones, or the uneven floor while walking around. Looking into the solutions or the wearable solutions, we may classify them into 2 parts, image-based or ultrasonic-based. The issue of the image-based are mainly the latency and the accuracy. So to be able to recognize the objects, that might take some time because of running the model. And for the ultrasonic based, they are using sensors, and the market doesn't provide with a high quality sensor. So there is a lot of problems with the sensors that needs to be filtered. And the objective of this work is mainly to be able to do wearable shoes. And the reason I've chosen the wearable shoes to be able to detect all the challenges and the obstacles that impaired vision might find while walking in the street, indoors or outdoors. So they provide a compact, lightweight, portable, hand-free product, and that is usually motivated by the parties that looking for providing tools to help the impaired vision. Again, what I find it interesting to do and go for the shoes, as you can see, the industry are motivated and they already have done some product to be able to provide data to the athletes. So for example, Nike, as you see in the picture, they have some form attached sensor to the shoes to be able to give some form of information to the person wearing the shoes. This work is mainly the system that we have developed is mainly looking for example obstacles like pit holes, bumps on the pavements or other obstacles that was pictures being captured from the university campus. And then we have designed the wearable system. Not only that, after the system was developed, we did some form of a filter on the data to be able to provide a good, reasonable kind of information to the impaired vision. And then later on, we were able to develop a fuzzy model to assess the level of risk in front of the user. This system, as you can see, that has multiple kind of sensor being attached around the shoes, on the left, on the right, in the front, to be able to capture most of the obstacles are surrounding this the human. And again, the range of that is around 10 meters to be able to capture and to give the alarm earlier before they got stuck with this challenge. We have used several kind of filters such as random forest, decision tree, KNN, and SVM. And we, with the data collected, we looked into the one that provided the better or the best kind of accuracy. In that respect, we found that the random forest classifier provided almost 99% accuracy with the data that we had. To develop the fuzzy system, we had to have the membership first. And we used the triangulation, and for each of the 6 sensors, we had the member function for them as presented on the screen. And then later on, we looked into the fuzzy rule-based model, and the system developed 30 rules. And we had from that 3 scenarios. The first one that has the low risk and the readings of each of the sensor being listed here, and the range of the risk is between the low risk is between 0 to 30. And again, if in the medium risk, the different kind of 6 sensors, the values of them is as listed here. And as you can see, the risk will be assessed as a medium risk between 31 to 70. With the high risk, you can see the values of the 6 sensors and the risk will be from 71 to 100. In that respect, the user will be able to understand how high or low the risk they are facing. Looking into the guidelines for having a wearable assistant device, we managed to be able to do a simple and economically accessible kind of tool, and it is wearable and does some performance and reliable. This work we see that is novel, affordable, and cheap, where it provides these kind of achievable, affordable, and wearable shoes to support the visually impaired. It helps them to walk freely indoors and outdoors because the sensors are mainly embedded in the shoes and can detect obstacles in front and in the back and in the right and the left. Again, having the filter that improves the performance of the sensors readings, that as well some form of an extra. In the future, we would like to do more empirical experiments with the users, however, in different environments, to give us more insight of what other things that we can add to the system to help the impaired users. Again, it will be good if we add the features such as the map to guide the impaired vision to the path and enable them to walk around. Thank you very much. I know that I didn't have much of time, so I did a very quick presentation. More details, you can find it in the paper. Thank you all, and I'm looking for questions. Thank you.
Most welcome, ma'am, for your kind presentation. I hope it would be helpful to participants. Firstly, I would like to ask to all participants if they have a question, please you can ask to presenter, or you can write on the chat box. We have 3 minutes for that. Okay, I'm waiting. Maybe during this time, I can a little question, ma'am. What is the main obstacle when you're running your research?
The main obstacle was the sensor. So I was worried, and that's what made me think of doing a filter. So I was apprehensive about having wrong messages to the impaired vision. So to enhance the quality, we thought about adding I thought about adding a filter, and in that respect I compared between the 4 kind of methods that the algorithm I have applied to enhance the performance and the reading from the sensors.
Thanks, ma'am, for your kind answer. Do you have any question? Dear participants?
Dear ma'am, if participant has any question, please write it down in chat box. So move ahead for the next presentation.
Okay, ma'am. Thanks for the valuable thoughts, the first presenter. The second presentation is by the Abdul Aziz ma'am. Yes, ma'am, this is your turn. You can start.
Hello.
Hello.
A very good day to everyone. So let me start with my presentation. So thank you for the opportunity of letting me presenting my work today. So my paper is IoT, Automated Pill Dispenser for Elderly Care. So my name is Haidatun Najwa Abdul Aziz. I am a UNICAL student from from Malaysia. So I have 3 other authors with me, which is Dr. Asmida, Madam Raidrami, and also Dr. Muhammad Hanif. So for the introduction, so this paper is fabricated to ease medication consumption, especially for the elderly that always forget the proper time to consume the prescribed medicine. Thousands of cases have been recorded throughout the decade of misconsumption of medicine. This may lead to serious issue as improper medicine dose is ineffective for the sickness that they suffer. The paper which really helps in eliminating the underdose and overdose issue, especially among the elderly, and ease guardians' worries about the absence at the moment of medicine consumption. So there are 3 project objectives. The first one is to develop an automated dispenser that triggers the alarm to the elderly. The second one is to record the medication drop data using TeamSpeak, and the third one is to notify the caretaker through Blink application. So there are 3 problem statements as well. The first one is the caretaker cannot keep on track of the elderly medicine consume schedule if they are already cited from NSD. The second one is most elderly do not know how to sort their prescribed medicine weekly. And the third one is elderly often forgets the respective time to take the medicine cited from NSD as well. So as per the project scope, to develop a device that can dispense the pills in the specified time prescribed by the doctors. The device will drop the medication into the container, and as the load cell detects the increasing weight of the container, it will trigger the buzzer to alert the elderly. The buzzer will only stop ringing once the container is taken out from its designated spot. At the same time, notification will be sent to caretaker through Blink application, and once the pills is consumed, another notification is sent. This way, the caretakers can monitor the frequency consumed medicine through ThinkSpeak. ThinkSpeak will record the data and the caretaker can observe in case any wrong prescribed times is not following the doctor's order. As for the limitation, sadly, the device is not portable. It needs to be placed on the flat surface and not very suitable for traveling, as it's quite a big and heavy device. Big and heavy device, elderly or the caretaker will have quite a hassle each time it needs to be transported somewhere else. As for the literature review, it is critical analysis. So I have researched on another 5 existing projects before. So all of the similarity for this project is they doesn't include all the features that I stated. For example, some project has application on smartphone, but it doesn't analyze the data, or some have reputable BC stated, but it doesn't have alert system. So basically my project includes all of this. So for the research methodology, this is, I use iterative waterfall model. So for the feasibility study is basically where I recognize the problem and also the project objective. And for the requirement analysis, I study for the hardware and also software requirements. For the system design, I study for the design of my project. Is it around design or circular design, or I confirm it on this phase. So the next one, implementation, is when I implement the system into real life for the hardware and also software. And then I do the testing, maintenance as needed, and documentation. So the first requirements is hardware. So there are 6 major hardware that I use. The first one is 14 segmentation dispenser. It is the base of the device that will be the interface for the user. The second one is Arduino at Mega 2560. It is the microcontroller device for the project. Then the third one is Wi-Fi module. Is used as the connectivity device to connect device with software. And the fourth one is buzzer as the element system. Stepper motor to rotate the dispenser. Then the last one is load cell to detect the weight of the pill dropped by the device and triggers the alarm. As for the software, there are 3 software that I use. The first one is Arduino IDE. The second one is Blink for the notification, and the third one is ThinkSpeak, which is a platform that can save and analyze the data. As for the flowchart, the caretaker first will start by turning on the power source and refill the pills into a segmentation. Then the LCD will choose the greeting, and every 6 hours, the stepper motor will rotate to 24 degrees, total in 360 degrees. So then the pills will drop in the containers, and the load cell will detects increased weight on container, and will trigger the buzzer. If the elderly did not take the pill container, the buzzer will keep on ringing and notify the caretakers. If elderly do takes the pills container, the buzzer will stop ringing and it will stop notifying the caretakers through the application, and also it will record the pill drop data using ThinkSpeak. Then for the project development, so the first one is input. I use the weight sensor, which is also known as a load cell, 1 kilogram load cell. Then for the microcontroller, I use Arduino Mega. There are 3 hardware output, which is LCD, buzzer, and motor, and 2 software output, which is Blink for the apps notification and ThinkSpeak for the data. For the IoT platform, I uses the Wi-Fi network connected to Blink and also ThinkSpeak. So this is my prototype, part 1, which is this dispenser. As you can see here, there are 14 slot pill compartment for each pill, 4 times a day. So the pill drop slot is hollowed, so the pill will drop every 6 hours. The dispenser is rotated using stepper motor. And then on the below of the hollowed compartment is the load cell that contains the container. The Wi-Fi module is used for the IoT platform. The buzzer is used to trigger the alarm, Arduino Mega as the microcontroller, and LCD for the greetings. For the pill container, I put it on top of the load cell, which is 1 kilogram load cell. It can measure from 1 milligram up till 1 kilogram. So this is Blink. Blink is my app's notification. So this notification will pop up on the caretaker smartphone every time the pills is dropped on every time the pill is dropped into the container. So as long as the pill is still in the container and the adult still doesn't take the pill container yet, it will keep on looping. So the caretaker can still monitor the medication intake even if they are away from the elderly. So it is ThinkSpeak that I use to keep the data and to analyze it into a simpler form, which is the bar graph for easy viewing. So for the results and discussion, so results we use testing. So dispenser is rotates, then pills are dispensed. Dispenser will remain idle as in the first picture until the 6 hours time interval approach, and then it will rotate to 24 degree for the pills to drop into the hollow compartment, as you can see in the second picture. And then the buzzer will trigger the alarm to alert the elderly. Besides that, the buzzer will trigger the alarm continuously to alert the elderly. The picture is the buzzer itself. So then the LCD will light up as an alert. The LCD will light up as the alert simultaneously and at the same time as the buzzer is ringing. So, and at the same time also, the blink notification will pop up on the caretaker smartphone as long as on the loop, as long as the elderly did not take the medication container out of its holder. Then the alert and notification will stop only if the elderly taken out the pills out of the container and put it back on its holder. So for the results, which is data, ThinkSpeak bar graph for analysis. So ThinkSpeak bar graph is used to is the further analysis step done by the doctors or caretakers if they need to monitor the medication time of the elderly. Then the data is stored in ThinkSpeak. So as you can see in the Excel, it shows that if the pills drop at 7 a.m., 1 p.m., 7 p.m., and 1 a.m. again. It will on loop as long as the power is on. So for the discussion, after finishing the user testing of the paper, some discussion resolved. One of the discussion is that each pill is varied in sizes and weight. So the compartment size should not be too small in case the elderly consumes bigger capsule compared to the tested pills. Next, the minimum weight that could trigger the system is 1 milligram. So anything with a lesser weight than the minimum weight might not trigger the system, but research done by Barrett 2005 stated that the elderly taken 4 pills on average for a daily prescription. So this issue is not a problem as these pills already exceed the minimum weight set for the weight sensor. Conclusion. This device is absolutely a great aid in making sure the elderly do eat their medication on time and eliminates the risk of underdose or overdose medication. The caretaker is also notified each time for medication as notification is sent at the same time as the pill is dispensed. The recorded data will help the doctor and caretaker to monitor the medication frequency of the elderly. As for the recommendation for future works, I recommend that portable design of device as it helps in making its feature more reliable. They could also add temperature and humidity sensor to ensure the level of quality of the medication. They could also include the camera features as a precaution to make sure that the elderly do take their medication on time. They could also make it a multi-user basis device. So these are the list of reference used in my paper. So that's all from me. Thank you. Any question?
Many thanks for your kind presentation, ma'am. I hope it will be helpful for participants. Now it is the question and answer time. We have 3 minutes. Do you have any question? Dear participants? Yes, we have a question.
So basically, okay, can I answer this? Okay, thank you. So how much power use does the system take? As I use the microcontroller, which is Arduino, it can be used on a regular power bank, which has a 5,000 mAh or something. It could also be plugged in onto the power source itself.
Thanks for your answer, ma'am.
Thank you.
We have 2 minutes for the question and answer.
It's done, ma'am. Please, you can announce the next participant.
Okay. Another presentation by Mr. Sander Gartner, sir. Also, thanks for your kind insights for the second presentation. Yes, Mr. Sander, you can start, please.
Okay, is my screen visible?
Yes, surely.
Okay. Hello everyone. Hope you're doing well. So the title of my the paper we are presenting is an evaluation of techniques for classification of conditional sentences and their structural components. Yes, wordy, but we wanted to capture exactly what we are doing in this. So to start off with, why exactly are we doing this? So many chatbots which are AI powered, we want to bootstrap them straight away by giving them technical guides or technical manuals, so that users can just communicate with them. They can just ask questions in natural language, and the solutions can be given by this chatbot. So a lot of such documents contain procedures, and they have different styles, but they're usually written step by step manner. And one core part of this are conditions, basically saying that if this is the problem, do this. If something else is a problem, do that. So that is one subset of the problem, where the problem is we're trying to bootstrap bots from technical documents. So this diagram shows a simple representation of how this would be used. So overall, to solve it, we identified 3 tasks to evaluate the techniques which we come up with on how this solves the problem. So we work on just single sentences. Again, this is another subset of the problem, but we just work on single sentence conditional statements. So classifying whether a given sentence is a conditional statement or not is the first task. Next is classifying the type of the conditional statement. This is sort of internal to our usage. Complex conditional statement is a condition which has multiple predicates, like multiple conditions, and then whatever the effect is. So this helps us process data easily, and also when we are giving solution results, this is useful there. And then finally, identifying which part of the sentence is the effect and which part of the sentence is the condition. So these are the 3 tasks we were able to identify. So here are some examples. So if prompted, agree to app request. So this is the task 1's output would be that this is a condition, and task 2's output would be that this is simple conditional. And finally, task 3 is where if prompted is the condition and the effect is agree to the app request. And similarly, a complex conditional here. So if there are no gears and the torque is low, so there are 2 conditions here joined by and. So this is again a conditional statement. It's a complex conditional statement, and there are 2 conditions which we need to identify, and we have one effect. So the data used in the evaluation, we thing is, this is sort of we didn't have any ready-made this database or anything on which we could train our models. So we had to pretty much build it from scratch. So we were focusing on technical documents mainly. So we went through WikiHow and chose a bunch of pages, and we went through even Lenovo's troubleshooting documents. And then we had to manually annotate it using annotation tool called WebAnno, which also lets you show relations between words and all those things, which was required, like relations with what is the effect and what is the condition, because sometimes the condition can come in the latter part or the former part. So this overall helped us, and it gave us a JSON output which we could use in Python to process the data. So the data is divided into two parts: single conditional statement and block conditional statement. As I said in this paper, we are focusing on single sentence conditional statements, not blocks. And then finally, we use the data set. We use the models we created to evaluate how they perform. So this is the stats of the number of sentences we have. So we the non-conditional statements were obviously a lot more than this, but we undersampled it so that there wasn't bias. So the first and usually most simple and used pretty much very widely in a lot of chatbots was the rule-based heuristic method. So here we analyze the data we had manually and try to figure out rules which represent it correctly. So for task one, we found out that conditional statements usually have a trigger word like if, to, when, or unless. So an example is given here: to restore your contents, return to the settings area. And similarly, another sentence. So one thing we noticed was if was one of the most frequently occurring trigger word in conditions. Next, a complex conditional statement usually has an or, and, or an or representing the relation between the conditions. And finally, the condition appears to the left or the right. We again had to infer something. You see that this does not perform really well because it's not that easy to get rules which work for all. But basically, if it appears to the left, there's usually a comma or something separating the effect in the condition in the effect. And in the second case, if it appears to the right, the trigger word itself is the partition. So we wrote, this is like some simple representation of a regex. We used NLTK PO styling to get the data into this form, and then we use the rules. So you can see the performance here. It performs pretty well for task one, given that it's such a simple model. But for task 2 and 3, the performance really degrades, especially for task 3. So yeah, one advantage you can say it's very simple to build, and one model can build work for all 3 tasks. But yeah, the disadvantage is that it doesn't really perform that. It's pretty much useless for the last task. The next approach we took was SVM. So for task 1 and 2, we pre-process the data using regular NLP processors, and then we classify them as simple conditional or complex conditional. So simple conditional, complex conditional basically are conditional, so that's task 1. And for task 2 also the same thing can be used. So that was one model. And for the task 3, we had features using TF-IDF factorization and PO tagging. And then we trained the model based on what we had annotated to predict which part was the condition and which part was the effect. So again, you can see the results here. So task 1 and 2 are significantly better. One of the most frequently used techniques in NLP pre-processing techniques is removing stop words. But as we told, a lot of our trigger words themselves come under stop words according to many libraries. So that takes away a lot of data. So we didn't remove stop words, and that dramatically improved its performance. Finally, we tried task 3 without PO tagging with PO tagging, and again, it performed better PO tagging, but still the performance wasn't that good. So finally, so here we can see that like task 1 and 2 performed with pretty good results, but task 3 was done only partially. And this was also probably due to the skew in the data set we had. Finally, the third approach used was rhetorical structure theory. So there's a discourse parser built on this theory, which we pass sentences to. This basically divides a given sentence into various parts, and it has its own definition for each part. So the task one was already in it, so it basically classifies whether a sentence is a condition or not. And the second part, it gives us the nucleus and this relative part joint, which means that that's the connection between condition and the effect. And so since it already divides the sentences into multiple nucleuses.
Mr. Sanders, sorry, you have 2 minutes.
Okay, sure, I'll wrap it up. So we were able to do task 3 as well. So here the key takeaway is task 3 here is performed really well, because this is mostly about going into the sentence and dividing into different parts and what it does. So so all 3 tasks were pretty good, especially the last one. The only disadvantage is training this on a large data set would require a lot of computation. So finally, the conclusion can be that task 3 was very well performed by RSP. Task 1 and 2 was comparable to what SVM did. So if you're trying to optimize how fast these things work, we could probably use a combination of these 2 models where SVM does tasks 1 and 2. And if it's found to be a condition, it can be passed on to task 3, passed on to the RSP. So that sort of optimizes things. Future works I can say is we need a good data set. Like there are more works that have come up which are doing something similar, but nothing is fully available in the public. So yeah, and trying out new techniques also would be interesting. These are the references we had, and any questions I'll be happy to take.
Many thanks, sir, for your valuable insights. I hope it will be helpful to participants. Now it is the question and answer time. We have 3 minutes for that. If you have a question, please, you can ask the presenter. Okay. Thanks again, sir. Another presenter is Mr. Yurak Landık. You can start, sir.
Thank you for opportunity. I hope you will see my screen. Okay, so once again, thank you for opportunity to present our work in this auditorium. I just repeat that our paper is focused to peak shaving in microgrids using hybrid storage systems. My name is Juraj Landak, and I come from Slovak University of Technology in Bratislava, Slovakia. So for my presentation, I repeat a few slides to introduce, to make some introduction into peak shaving process and terminology and hybrid battery environment. Then I would like to quickly talk about our simulation environment that we proposed in MATLAB and we used to evaluate our simulated microgrid environments, and then I would like to conclude to some interesting simulation results and conclusion of the paper and some thoughts about future work and future extensions. So, as I already said, main topic of this paper is focused to peak shaving, which can be, generally speaking, could be described as some kind of strategy, how one customer can deal with its peak load energy consumptions from grids. Many different strategies and approaches. We've choose to focus to on-site battery strategy, where these batteries are used to charge during the low cost or off-peak hours when there is enough energy to be consumed. And during the peak loads where we are hitting our tops, we use this battery to discharge. And mainly we would like to, during the discharge periods, we would like to avoid some peak prices of energy on the market, or to avoid exceeding of the reserve capacity limit, as this is one of the main characteristics in Europe energy markets. So as it's already obvious, main aim of this peak shaving strategy is to save on energy bills, or be more green in or more secure in the distribution network. Second main goal or main topic of this paper is hybrid battery, as it is already defined. Anything that combines two or more power sources could be understood as a hybrid battery. Where important characteristics is that these two different power sources should have different energy characteristics. For this paper, for our work, we've decided to deeply analyze hybrid battery consisting of conventional chemical battery and supercapacitor, as we believe that this combination combines individual advantages of both of these separated batteries, where batteries have high capacity and a relatively low cost watt per hour ratio, but also it has very long or quite long charge times and low discharge currents. On the other hand, supercapacitors are quite expensive still nowadays, but have quite quick short times, quick charge times, and unfortunately low capacity but high costs. Here's the conceptual illustration of our smart grid simulation, which we proposed and developed in we programmed by our team in MATLAB using mainly object-oriented coding in MATLAB environment without any inbuilt tools. It is based on modular architecture, as it can be seen here. That it's consists of separated modules of energy consumption, consumer, power generator, air, and already mentioned energy storage, which also the hybrid battery is one of them. For now, it has no graphic environment, but it's still ongoing work, and it is already published open source on a GitHub, so it's open to next further extensions and next work. Using this smart grid simulator, we've chosen we believe two interesting scenarios for this paper. I would shortly describe them here and talk about the results, which are deeply described in paper itself. Scenario one is a comparison of hybrid battery storage algorithms. As I already said, the hybrid battery consists of two different parts. We call them internally as slow part, that is the chemical battery, and the fast part, the supercapacitor. From heart, one can imagine that there could be more charging and discharging algorithms that come to the table when we think about it, and we try to evaluate four basic alternatives when we work with charge order and discharge order of all the parts. For this evaluation, we created a power source that was superposition of two periodic signals. Both of the signals can be easily peak shaved by each part of the battery. One quick signal that can be easily peak shaved with fast part with the supercapacitor, and second signal that can be easily shaved with this slow battery, classical chemical, but only until the slow battery is fully discharged. So this evaluation scenario was constructed to somehow fail at some point. All of these batteries should fail at some point of this test, and we tried to watch which of these algorithms will be able to last longer. As I already mentioned, in paper there are quite deep discussion about all of these algorithms, but for this presentation, I just jumped to the winning scenario, which is algorithm number one, where fast battery is firstly charged and also firstly discharged in this for this signal, for this current. And we can see here that in these algorithms, our proposed battery could last for 123 steps of the simulations. Just to notice that the worst scenario for this type of signal was algorithm number 3, where slow battery is charged first.
Sorry, Mr. Rondek. Sorry, you have 2 minutes.
Okay. Well, I'll do it. And this algorithm only lasts for 20 steps of these simulations. So quickly to scenario number 2, where we try to evaluate potential savings of this hybrid battery using in the real life consumptions profiles where we obtained. Basically, we would like to explore the potential of the hybrid battery usage by receive capacity decreasing with this specific battery size. Some of the interesting.
Dear presenter, your last 1 minute, please.
surprising observation of this scenario, which again is more described in the paper itself, that for for this specific current profile we examined, that the quite fines are not linear, and it could happen that during the while having the smaller receive capacity, we could have larger fines, and vice versa. So the lesson learned from this is that for every detailed explanation is in the paper. The system have to be performed with the load profile, with specific load profile in mind. So thank you for time. I will not go to future work. Let's jump directly to question if there are some.
Thank you so much, dear Landik, for your kind insightful. I hope it will be helpful to all participants. Now it is the question and answer time. We have 3 minutes for that. If you have a question to Dr. Landik, please ask. Okay, if there isn't any question, we can pass another presentation. Thanks again for the valuable insights, dear professor. The 5th presentation is by Valentina Narvaez-Taran. Ma'am, yes, you can start.
Hello, give me just a second to share my screen. Can you hear me properly?
Yes, surely.
All right, thank you. So, hello, thank you so much for everybody being here. I am Valentina Narvaez-Taran, and I am presenting preliminary results on constraint programming and branch and bound algorithms for the cyclic bandwidth sum problem. This research was developed in collaboration of Simvestab, that is my institution. It is the Center of Research and Advanced Studies of the National Polytechnical Institute in Mexico and the University of Angers in France. Oh, I'm sorry. I am not using the presenting mode. Give me just a second. All right, the presentation should be showing properly now. So let me first introduce quickly the cyclic bandwidth sum problem. That is the problem we dealt with. It is a graph embedding problem, which are problems that deal with determining the best way to incrustate a guest graph into a host graph in such a way that vertices of our graph, that is the host, are hosting vertices from the guest graph, and guest edges are embedded into paths of the host. Specifically, the cyclic bandwidth sum problem has the characteristic that the host graph is a cycle. And the objective of the problem is to minimize the sum of cyclic distances between adjacent guest vertices when they are embedded in the host, where a cyclic distance is the length of the shortest path between embedded adjacent nodes from the guest embedded in the host. So, for example, this is how an embedding of a graph embedded into a cycle of order 6 would look like, with the guest vertices embedded into the host vertices and the guest edges embedded into the host paths. Then the sum of the length of those paths, that is equal to 10, it's the cost of this particular embedding, this particular solution. So formally, we have the guest graph that is simple, finite, and undirected, and the host graph, which is a cycle graph of the same order. And giving an injection of guest vertices to host vertices that represents an embedding, the cyclic bandwidth sum for this graph with respect to an embedding is defined as this sum of the cyclic distances. Therefore, the problem is to find the optimal embedding such that the cyclic bandwidth sum is minimal. So that is the problem. So why did we choose an approach based on exact methods? Well, to begin with, the problem had never been approached by exact algorithms, only by approximated ones, heuristics, and meta-heuristics. But we knew that the exact methods can be very effective when obtaining optimal results, especially if employed appropriately for relatively small instances. And knowledge about the optimal was desirable, not only for having the optimal solutions, but also to be able to use that knowledge about the optimum in further problem analysis, for example, in fitness landscape analysis, for applying techniques such as fitness distance correlation that rely on knowledge about the optimum. So our proposal was to use constraint programming. We knew it could get great results with a relatively small investment, and the main challenge being how to properly model the problem. For that, we employ Minisync and the default solver, G-code. And since there was no other exact algorithm proposed for the problem, we developed and implemented a branch and bound algorithm employing C. And we tested these two approaches in relatively small instances of 40 or fewer vertices. So for the constraint programming approach, we developed 3 models and we incrementally refined them, adding new constraints. All the models have the same input variables, that is the number of nodes, the number of edges, and a listing of the edges. Then the final model has also lower and upper bounds that are topology specific. Our decision variables are simply a labeling that links host vertices to guest vertices. And the objective is to minimize the cyclic bandwidth sum, that is the sum of cyclic distances. So the first model focused solely in getting valid solutions. So valid embeddings that are these bijective mappings between guest and host vertices using the global constraint, all different. Then the second model focused on removing isomorphic solutions by breaking cyclic and mirror symmetries. And finally, the third model has the further information about the problem included. that is upper and lower bounds that are topology specific for the instances that we were testing. Now, about the branch and bound approach, the main highlights about the branch and bound are that it uses a depth first search exploration of the guest graph in order to get an initial complete solution that is used to establish a bound from the cost of that solution that is then used to prune branches during the exploration. Then we begin with a partially defined solution that simply assigns the first label, that is the first host vertex, to the first guest vertex. And that partially defined solution goes into a priority queue. So we conduct the exploration by getting solutions from the queue. And when we get a solution from the queue, we decide if expand further that branch or if discard it by using a sum of partial plus potential base case codes. That is based, the partial code is based on the defined part of the solution, and the potential best case codes is based on, well, the best case scenario for the undefined part. That is, if all the edges that are not yet fully defined, that we cannot get yet the cost, the cyclic distances for them, if they have a value of 1 each. And then when we decide to expand a branch, the solutions, the new solutions from that branch go back into the priority queue. And that queue has a composed priority. It is first based on the order of the solution in order to get a fully defined solution as soon as possible, so that will help us reduce the bound and then therefore help us to further do the pruning. And then the secondary criteria is a heuristic estimation of the potential best case cost if one of the edges that it is not yet fully defined, but has one of the endpoints defined, was to be assigned the most suitable label. Now, for a quick summary of the results that we got, we tested 57 graphs. 37 of those have a known optimal value via exact formulas that are based on their specific topologies. And then also we had 20 other graphs that had unknown optimum that included Cartesian products, random graphs, and Harrow-Bohm graphs. And specifically for the Cartesian products, there is not a formula that gets us the value of the optimum, but there is upper bounds estimations. And for the experiments, we set a time limit of 1 hour. The results were that with the first model, the one that has only constraints for getting valid solutions, we were able to solve 35 graphs. Then by removing isomorphic solutions, that allow us to solve 9 graphs more for a total of 44. Then adding the topology specific upper and lower bounds help us to solve all the 57 graphs with the third model. Also, the time that was employed to produce the optimal solutions by each of the models was progressively reduced, and the order and the size of the graphs that were solved was progressively increased. And finally, comparing with the branch and bound algorithm, we found that it was competitive with the two first versions of the model, even better. But the third model was able to dominate over the branch and bound algorithm. Considering,
sorry, ma'am, your time is over.
Oh, well, it is almost done. The main highlights are that we solved 57 instances, 20 of them without previously known optimal values. We found a gap of 16.8% with respect to the upper bound of the Cartesian products. We got optimal solutions that can be useful in further problem analysis, specifically fitness landscape analysis. And for further work, we will be interested in expanding the types of instances that we consider and further refining our CP models, adding more refined cost bounds, search strategies for variable assignation, and possibly warm starts. So thank you so much. I'm sorry I went over my time, and I am open for questions. Thank you so much for your attention as well.
Thank you so much for your valuable insights, ma'am. Now, the sixth presentation is by Galia Kondova. Galia Kondova, are you here?
I think this presenter is absent.
Mm-hmm. Yes, ma'am.
So we have completed all the presentation, and I sincerely thank our authors for the excellent presentation and the contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative. All the presenter would be getting their digital certificates within 2 working days. Further, all the paper has already forwarded to the Springer, and the publication will be live within 5 to 6 months. Kindly cooperate with the team of ICICT. And I also thank our chair for this session, Dr. Gul. Thank you so much, ma'am, for your valuable time and your presence. And I would like to ask, display the certificate. This is a token of appreciation on behalf of Team ICICT and Global Knowledge Research Foundation. Thank you so much, ma'am. And one more thing, dear all, I kindly request to turn on their cameras for a quick snapshot for this virtual conference, for making this conference more memorable. Thank you so much, everyone. Thank you so much, ma'am. Thank you.